Hello everyone, here straight from our mission control tent over in Aldenhoven. As you can see with the graphic on screen, we just started fueling and we already have roughly 5.8 kilograms in the N2O tank. Fueling will continue for the next few minutes, and after that we'll continue with the checks. And we're still planning for the T0 at 4 p.m. local time. As you might have seen on that fueling infographic, we have just finished N2O fueling, and we pushed the T0 by 15 minutes to give us a bit more time to get everything ready here. And next up is N2 fueling, and yeah, commentary will start soon as well.
Hello, hello, and thanks for joining our stream again today. Um, we are just finished up the fueling of the N2O tank and are now filling up our N2 tank. For the people joining us, like in the stream from yesterday, yesterday we had an attempt to test fire this rocket, and that attempt sadly had to be scrapped due to issues with our tanking procedures. But these are now fixed, and we successfully tanked the rocket. So it's close to fully loaded right now. Just finishing up the N2 loading. And we're ready to hotfire it in around half an hour. Thanks for joining us so far. I will give a quick summary of what we are actually doing here, give a little bit of context, what this project is, and we'll try to answer any questions you have. So please feel free to put them in the chat if you want to know more about this. Um, First of all, what's actually happening here today? Today, we are attempting to test the propulsion system of our project Astrid for the first time in a vertical configuration. So we have this hybrid engine that's self-developed by a team of students. And today we are testing it in a vertical position. We have test fired it quite a lot in a horizontal position inside of a test stand. So basically inside of a container. Um, and now we're testing it in a vertical configuration. That means all the flight tanks, all the flight valves are in the same configuration. We will have them on the rocket itself. Currently, the rocket is not fully assembled as, for example, the recovery system with its parachutes and the electronics are missing as they're not required for this test. Um, okay, maybe let's get into a little bit of context. What is this project Astrid we're testing today? Um, we have 1 second. I have to pull up something here. Um, project Astrid is a project which is part of the Space Team Aachen. The Space Team Aachen is a student initiative here in Aachen where students can build and develop their own aerospace project next to university. So basically, we are doing this in our free time because we are excited about rocketry and are excited about um, getting hands-on experience with, yeah, aerospace projects. Um, and so this is our hybrid rocket for the European rocketry competition, aimed to launch this October, so not that far into the future, in as part of the European rocketry competition, which is a competition where student teams like ours build and bring their rockets to Portugal and compete against each other in a point scoring system to basically build the best rocket, to engineer the best rocket for this competition. Um, there are different categories in this competition, and they're mainly divided by the altitude the rockets are flying to, which are 3 and 9 kilometers, and the propulsion system of the rocket. So there are different types of rocket propulsion systems, starting out with a solid rocket. So it's just solid propellant. It's kind of similar to basically a small rocket you would launch on New Year's Eve, but just scaled up to larger scale. And then you have the hybrid engine, which is composed of a solid component and a liquid component. So for proper combustion to take place, you need an oxidizer and a fuel. And in a hybrid engine, we have got this fuel in a solid form and the oxidizer in a liquid form. This is what Project Astrid is. So we were just loading the N2O onto the rocket. This is our oxidizer. And then we have wax or paraffin as our fuel in a solid form inside of the engine. I can show you a little bit more in a second with a cross-site view of the engine. And the final means of propulsion is the liquid engine, which basically has its oxidizer and its fuel in liquid form and mixes them inside of the combustion chamber. So this is the different types of propulsion you've got inside of the EROC. And Project Astrid, as I already said, is a hybrid engine, which aims to fly to 3 kilometers in October this year. And to actually fly there, we have to do this test, which is a vertical hot fire of this hybrid engine. And just to get a little bit into it and understand what we are actually testing today and what you are about to see, and a little bit about the test site, we have a small video prepared where our propulsion lead takes you through the test site and basically shows you around what we are testing and how we are testing it. Maybe you can play that right now. Second.
Right now we are here at the test site for a vertical hot fire. The vertical hot fire is necessary for the EUROC as a major requirement prior to flight in October. The test site here consists of multiple entities. This is the launch rail. This is where the rocket is standing. Then there we have the mission control tent. This is where all the operations are ongoing. And right behind you, there is the preparation tent where our engine right now sits for installation. And this is what we'll look at first. Right now here in the preparation tent sits the toothless engine. This is the engine that will go onto the launch rail and will be fired into the hot fire today. And this is the igniter cable that will light the engine. This will be connected to the computer on the launch site and will remotely ignite it. You will get a deep dive for the whole engine here later in the stream. We'll show you a cross section of the engine and talk about how it works. This is the launch rail. This is where currently part of our rocket is assembled. And this is our own launch rail. And we built this launch rail especially for the Euro competition. We will bring our own launch rail there. This has many benefits. And this launch rail right now is only, I think it's like 1/3 of the size it will be. It will be 16 meters long. Yeah, and let's take a closer look. The launch rail is anchored down by several points, here, and right there. And it's additionally secured by 2 IBC tanks, each weighing 1 ton. Right here at the backside, we have our FGSE and EGSE. Those are both responsible for the fueling operations that are underway right now. Right now here we have the N2 fueling line and the N2O fueling line separated. And right here, currently covered is the N2O bottle. This is the main oxidizer of this rocket. This right here is the test article. Here, the toothless engine will be installed. This is our main valve. This is the main fuel line. And then on top of that, we have the oxidizer tank. And on top of that, the main fluid system. And above that, the pressurization tank. The Poseidon water deluge system is not here. This is just because we don't need the noise reduction. And it's cool for us as well because some of us didn't even hear how the full power toothless engine sounds like. Toothless is still super powerful. So we've installed this flame diverter, welded by ourselves down here. This will redirect the flames and make sure that we don't have flying debris all over the place and make sure that the flames go in a predefined direction. This should give you a good overview what's on the launch rail and what will be actually tested, but let's head to the mission control room and or the mission control tent and see what's controlling today's test. This is our mission control room. It's a mess right now, but as you can see, we're in the final preparations for the Hotfire tomorrow, so cleanup is next. Right here, we have multiple screens monitoring the situation. We're using EMCS to monitor the rocket data and the ground support equipment's data. Yeah, then here's the streaming cabin, and yeah, that's basically it. And yeah, I think with that, you got a good overview, and enjoy the rest of the stream.
Okay, so now as Jakob showed you around, you have quite a little bit more insight into how this test site is actually set up and what we're actually testing today. And just to answer the question real quick here, what's the total amount of nitrogen that needs to be fueled? What's the target pressure and temperature of the N2O and N2? So we have around 10.8 kilograms of N2O, and N2 is around 1.2, 1.14 kilograms of N2 at a target pressure of 150 bars for the N2, which then during the hot fire pressurizes our N2O. So I hope that answers that question. And we can take a look at what's actually going on with this rocket. If we jump to basically an have a total of roughly 5 meters of rocket, me up 7 meters in length, and this rocket currently not in that way on the launch pad. Only the systems critical for the propulsion test are actually on the pad. As Jakob already talked about in the video, the center of the rocket, the core, are the two large tanks which hold our oxidizer and our N2 to pressurize our oxidizer. And besides that, we have different sections holding our fluid systems, so our valves, our electronics which control the valves, and then furthermore, this rocket needs to come back down. So we are trying to get this rocket back with parachutes. So we have a total of 2 different parachutes on board, which get deployed at different times. So we have a small pilot parachute, basically, which gets deployed on apogee. So we deploy a smaller parachute at 3 kilometers to slow down and control the descent of the rocket. And then we have another parachute, a larger parachute, at around 500 meters to basically direct the final touchdown velocity and make sure the rocket has a soft touchdown. And to even further the basically touchdown velocity and the impact the rocket is taking while hitting the ground, we also have an airbag system on board. So we have 2 large airbags which get deployed around and under the rocket to protect the rocket on basically the final impact on the ground. Yeah, so these are the different sections of the rocket, and they all have their purpose to build up this quite large vehicle in the end with a total of 64 kilograms of liftoff mass for only a flight duration of 170 seconds, so not even 3 minutes of total flight time. Most of it spent under the parachute coming down. And maybe let's get back to the star of today. So we have the propulsion system today in the focus, which consists of the hybrid engine, which we have installed on the bottom of this test bench here. And this hybrid engine consists of different parts. You can see in this cutaway view a view of it from the stream direction left to right. So on the left side, we have our oxidizer entering through our injector and then going through the fuel grain. So this is basically our fuel in solid form, as I mentioned before, burning from the inside out. And then we have a mixing disk, which you can see more closely here, which introduces turbulence and ensures a full and efficient combustion. And then we have our nozzle, which consists of basically the nozzle insert, which is a graphite part, which can withstand the immense heat at the choke, so the smallest area of the nozzle. And the nozzle structure around that made from Pertinax, which is an ablative heat shield material, basically. And so we got our stream going from left to right through this engine. And on the right side, we've got the exiting supersonic flow of our combustion gases. Yeah, so this is basically how this engine is built up. And as already mentioned, we tested this engine quite a bit in a horizontal configuration inside of a test stand. And today is the first time we're testing it in a vertical configuration. So all the main valves and all the fueling processes and so on are identical to how it will actually be set up on the rocket, but on the pad right now is not a fully assembled rocket, as we have the whole system basically strapped down to the ground. In some shots, you can see the large water tanks, which basically ensure that this rocket can't lift off and stays on the ground today, till October, when it actually lifts off. Yeah. So if you have any questions, feel free to ask them, and I will do the best to answer them. Other than that, we have around 10 minutes to go. And in these next 10 minutes, we have some final checks. And if everything goes to plan, we have our supercharging. This is basically the final pressurization of the system, which you could say which arms the propulsion system, so it makes it ready for firing. And then we have our auto sequence, which starts at 30 seconds, where basically it's a pre-programmed section of the sequence where everything runs automatically. There's no intervention anymore. If the test is not aborted or some values hit certain out of range targets. So we go hands off in that moment and basically let it run. And then we have the ignition, and we are firing for around 8 seconds today. And after the burn, we have a purge, which basically ensures that nothing is left burning and our fluid system is completely empty and safe to approach afterwards. So nothing is left remaining in the tanks, and we can ensure that no pressurized tanks are still on the pad when people go there afterwards. Yeah. Okay. Today you can actually see our bottle flipping apparatus in the back, which is used for tanking. So we have in the back in this shot, you can see with the golden basically foil around it to keep the bottle at temperature. And we have an even better shot from the backside. Here you can actually also see the fluid system and the ground support system, which basically controls the whole fueling process and basically provides all the fluids in the right places at the right pressure. This is made possible with this valve panel on the right side, and on the left side we have basically the electronic side of it, because we have basically the valve panel, which is for the fluids, and on the left side is the electronics which control the valve panel remotely from the mission control tent as it is today. Yeah. Is the weather okay? Yeah, actually the weather is quite awesome. It's not raining anymore, so our crew out there is not suffering as much as yesterday. Yesterday it was basically raining all day long. So they were actually quite cold after a day setting up and basically preparing everything in the rain. This is not the case today. We have overcast, but not too hot, not too cold weather, which is actually really good for this hot fire. No, we're actually not firing directly towards a street. We first of all, today we're firing downwards, which even reduces the basically the direction and danger radius. But this is also a closed off area where we can ensure that nobody is in a safety radius around this test site. So actually we can ensure the security around this test site. Okay. So Julia is asking how many people are actually taking part in this project. So in total, Project Astrid is around 30 people who actively work on this, but this is not only spent on basically the propulsion side of things, but we have also people working on the avionics, on the structure of the rocket. So basically laying up carbon, designing PCBs, and doing antenna design and testing and range testing and so on. So the propulsion team is, I think, 6 to 7 people, but helped by quite a lot. So the teams are not that strict. So today, actually, a large part of this team is involved in this test, especially because it's also across disciplines. As already mentioned, for example, the valve panel is controlled via self-designed PCBs. So this are actually multiple teams working together today to make this possible. And apart from this project, we actually have more projects. So the student association is roughly 150 people working on different projects, not only this rocket, but also other rocket projects and a rover and so on. So we're actually not only doing hybrid rocketry, but also doing quite a lot of other projects. Is it fueling? No, it's actually done fueling. So the rocket is fully loaded up, and we have all the N2O and N2 on board, except for the final supercharging at T minus 2 minutes. But the loading of the propellants is basically done. any launch soon after this. This rocket is designed to launch in October. So for a rocketry project, this is quite soon. But in the till October, so I think 15th to 21st of October is the European rocketry competition where this rocket is going to be launched. There are no launches from our association. Yeah. But keep an eye out for other live streams. We do them quite frequently for tests and other stuff. We quite like to share what we are actually doing and doing that live with you. So we're coming up on the supercharging, the basically final major step before starting with the sequence and going into this Hotfire. So it's getting closer. Just so everyone understands where actually you have to be looking in 1.5 minutes. This is the whole setup, and right in the basically at the bottom of the tower is the actual engine mounted. So we have these large water containers in the back, and then the flame diverter at the bottom, which is basically the steel piece on the bottom of this. And above that, you can see metal cylinder, you could say. And this is our engine. There's the flame coming from. You can also see that in the top left shot, where basically you've got the engine in the top left corner firing downwards. Yeah. Final seconds now for everyone just joining. We have a final hold at T-minus 30 seconds for the first vertical hot fire of our hybrid engine for Project Astrid. This hold is due to final checkouts. It's a planned hold, and we will continue as soon as we have the go from all teams to basically hot fire this. What will happen with the project and star after Astrid's launch? We actually will continue. We have already a project set up and starting out, which will follow in Astrid's footsteps. Project Icarus started to basically understand what Astrid is doing and will iterate on Astrid, will take their rocket and improve it and build up on all the problems and good stuff. Yes.
Streaming. Go.
Okay.
Engine. Go.
We have the mission control audio.
System. Go. EMCS. Go. Safety. Go. Firefighter. Go. And test leaders also go. No, activate the siren. 1 second off, 1 second on, repeat 3 times. Start EMCS sequence.
Sequence started.
Supercharging. Supercharging done. Waiting for ignition permission.
Okay, check if supercharge pressure is correct.
Should we add something?
I think we should have a little bit. Let's wait it for a few seconds and then top off again. Top off. Top. Shit. All good. Let's wait a bit. We can still vent. A little bit. Yeah, I'm for vent a bit.
72.
Okay.
Okay. Good. Check if supercharge pressure is correct.
Check.
Pull out red button on the safety box.
Check.
Turn ignition key on safety box.
Check. Check.
Okay. Give ignition permission in the MCS. Afterwards, the sequence continues.
Okay.
And activate siren at T-minus 10 seconds.
Sequence started.
Nach Aufruf.
T-minus 25. T-minus 20. T-minus 15. T-minus 10. T-minus 5, 4, 3, 2, 1. Ignition.
Okay, and we're back. That did not quite went the way we wanted to, but it's not a major issue. Maybe you could already see in the we basically had ignition, and we actually then had the main valve open. We ignited the chamber, but it seems like we had a leak above that. From what I could gather from here, you could see basically the N2O venting above the combustion chamber, leading to a flame out inside of the combustion chamber. We are still trying to figure out what that exactly means. The site is safe. We did not have any major issues, except for basically this leakage and not successful um, vertical hot fire. But that means we will repeat it, and that also probably means we will repeat it on the next live stream. I don't know quite when this will be. This will still have to take a second till the team on site can understand what actually happened and what it takes to fix it. It did not seem like a major issue. It seems like a quite fixable problem. And I hope we will be back with a new stream starting soon. I'm not quite sure when yet, but yeah. So thank you so much for joining, and then see you hopefully in the next stream when we attempt again to hotfire this engine. Until then,